The PicoScope is a high accuracy measurement instrument and can be used to measure the output level or gain of any audio device, for example amplifiers, mixers or equalizers. In this example we're going to be measuring the gain of an amplifier. So we have two channels available, A and B. So I'm going to use channel A to monitor the input signal and channel B to monitor the output signal and measure the gain across the device, which is say an audio amplifier. Before any tests can be performed, the amplifier or device under test has to be set to a known condition. So for example, the bass and treble controls have to be set to flat and any loudness controls set to a known state, so a calibrated test can be made. It also has a generator, so we can generate very high accuracy known signals. So it can generate a number of types of waveforms, but for audio tests typically sine waves are used, as this has just one frequency component and then can be used for measuring total harmonic distortion, etc. The frequency can be set and the amplitude. For this test I'm going to set the amplitude to 100 millivolts, and this has then been connected to the amplifier input and also to the channel A input via a ×10 probe. So I'm just going to set the probe factor to ×10, and this ensures that the vertical scale factors then read correct for that particular probe. The channel B is connected to the output of the amplifier, in fact across the 15 ohm load terminating the output, and via a ×10 probe again. So I'm going to set the probe factor to ×10. So now we have the two channels defined. I'm going to run the acquisition. So here we see in blue this is the input signal and the red is the output signal. If I just change the gain of the amplifier, the volume control, we can see that the input is static whereas the output level changes. So I'll just set this to that particular level, and then we can perform a gain test at this particular setting. So now I can stop the acquisition as we have the acquired data, and we can now perform the measurements to measure the gain. So the first thing I want to do is measure the amplitude of the input and output signal. So under measurements we can add a measurement, and I'm going to measure first the input signal, that's channel A, and measure the peak-to-peak value of the input. So here we see the 100 millivolts, which was selected on the generator, and the output, and add a second measurement. The output is on channel B. We select that and again measure the peak-to-peak value of the signal. So on this particular amplifier gain setting, the gain is A divided by B, so the gain is ×14. But it's very easy, you see, to monitor the input and output levels. This is called the overlay display. We're overlaying channels A and B on one panel, but they can be displayed in separate panels. So under the Views menu we can select a new layout of two viewports. So now we have viewports 1 and 2, and I can set the second view, select the second viewport and then add signals to that. So I'm going to add a second scope display. So now we have two scope displays, both displaying channels A and B. But further now we can select which waveforms we display in each panel. So we select the panel, and then again under the Views menu we can select which channels. So again channels A and B are displayed, so I'm going to hide channel B. So now only channel A is displayed in the upper panel, and then similarly in the lower panel select the lower panel, and under the Views menu under channels now I'm going to hide the input signal, so we're only displaying the output signal. So again here we see the input and the output signal, and in this view we can actually name the panels. So I'll select the upper panel and I say this is the input signal, so I'm going to rename the view to a more meaningful name for this particular application, and obviously going to call it input. And similarly with the lower panel, select the lower panel. See now it's highlighted with the black outline, so we can now rename the lower panel, and indeed obviously this is the output signal. This is very useful for producing hard copy or documented results, so it gives a more meaningful name. Finally we can add the measurement back onto the new panel. Again select the panel and then under the measurements add another measurement, again channel B and measure the peak-to-peak value. So here we're performing the same measurement, the input level, the output level, but now as two separate views. So this is a choice on the documentation type of view required.